Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800/800 guy, is teaching calculus this year. Watch his videos.
Alright folks, what's up? Today we're looking at another example of finding the equation of a tangent line. Why? Because it's important. So let's take a look at another example. Find the equation of a tangent line of f of x equals the square root of x minus 1 at x equals 5. So whenever I try to deal with these questions, I try to get a geometric perspective of what function I'm dealing with. So what does the square root of x minus 1 actually look like? Well, you should know how its parent function looks like, right? The parent function of that is simply square root of x. So if we shift all the x coordinates to the left once, it's simply going to be looking like this, -1. So yeah, this is how this function f of x looks like. So what are we being asked? What we're being asked here is to find the equation of the tangent slope at x equals 5. So this is the point x equals 5, and we want to find the tangent, the equation of the tangent line at x equals 5. So how do we do that? Well, first things first, I want to, as before, I want to find out the coordinates of the point that I'm finding the tangent at. How do I find the coordinates? Well, I simply plug in 5 into f of x, right? So if I plug in 5 for x, what do I get? Simply square root of 5 minus 1, which boils down to 2. So that means the coordinates of the point at which I'm finding the tangent at is 5, 2. That's going to come in handy later when we try to find the slope of the tangent. Okay, so what should I do now? Well, I found the point, the coordinate at which I'm finding the tangent. Now I'm going to find the derivative of this function f of x. Why am I finding the derivative? Well, the definition of a tangent line, to find the slope of a tangent line, I need to find the derivative of f of x at this point. Okay, so if you remember the limit definition of a derivative, it's the limit as h approaches 0 of f of x plus h minus f of x over that same the difference in the x-axis, x coordinates. Okay, so we have the limit definition of a derivative. So how do we use this? Well, we're going to apply this problem to this formula. F of x in this case is the square root of x minus 1. So instead of x, I'm going to replace x by x plus h. So how does that look like? Well, I'll get limit as h approaches 0 of x plus h minus 1. Okay, and then I just have f of x, so minus f of x. What is f of x? It's simply x minus 1. And then if you simplify the denominator, I'll have my x's cancel out and I'll be left with an h. Okay, so far so good. We're trying to find the equation of the tangent line at x equals 5. So we know what x is. X is 5. So why don't we put that in? If we plug in x equals 5, this simply becomes the square root of 4. And what about this? Well, the left-hand side simply becomes 4 plus h. 4 plus h. Okay, now it's just a matter of simplifying this limit, right? Whenever you see a square root, or whenever I see a square root, what I try to do is use the conjugate somehow. So it turns out that the conjugate actually works in this case. If you the problem here, the reason why I'm trying to use a conjugate is because if I just directly plug in 0 for h here, it's going to come up undefined, and I don't want that undefined for my limit. So instead, I'm going to multiply this limit by the conjugate. If you don't remember, the conjugate just flips the sign, and the reason why we do that is so that we get a difference of perfect squares. Alright, so what happens after I multiply by the conjugate? Let me bring my work here so I have space. So the limit as h approaches 0, of course you'll get difference of perfect squares, 4 plus h squared minus 2 squared, and we'll have that divided by h times 4 plus h plus 2. So h times 4 plus h plus 2. Okay, now all we have to do is simplify this. Square and square root cancel out, so we're left with a limit as h approaches 0 of 4 plus h minus 4, and go ahead and divide that by whatever this is. I'll keep it unfactored, you'll see why. Actually, you probably already know why. It's gonna cancel out with something. Plus 2. Okay, you see the 4's cancel out, right? Or rather, they sum up to 0. And I have h on the top, h on the bottom. Let's cancel those out. And what am I left with? I'm left with the limit as h approaches 0 of 1 over square root of 4 plus h plus 2. Alright, great. Let's plug in 0 for h so that we get square root of 4 here. Square root of 4 is just 2, and 2 plus 2 is 4. And limit of a constant is just that constant. So our answer is going to be 1 over 4. But remember that this is actually not the final answer. This is the slope of the tangent line, but we're asked to find the equation of the tangent line. This is a common mistake made by many middle schoolers. So, how do we fix this mistake? Well, it's not a mistake at all. We're just not done with the problem yet. What we're going to do is use the point slope form of the equation of a line, which is y minus y1 equals m times x minus x1. And we're going to use the slope of the tangent line in conjunction with the coordinate at which we're finding the equation of the tangent line to find the equation of the tangent line. Okay, so what is our x1 and y1? Come back here, you see our x1, y1 is 5, 2. 5, 2. What is our slope of the tangent line? 1 over 4. So we have everything we need. So instead of x1, put 5. Instead of y1, put 2. And for the slope, we can just plug in 1 over 4, right? And of course, since we're finding the equation of a line, it's imperative we isolate y. So we get 1 over 4x minus 5 plus 2. Let's go ahead and simplify that. We get 1 over 4x minus 5 over 4 plus 2. 2 is just, what? 2 is what? 8 over 4, right? So this simplifies to plus 3 over 4. Plus 3 over 4. Okay, folks, so this is the equation of our tangent line. And now, thank you for watching.
Science Lab to fall in love with math and science, especially programming.